Welcome to number patterns. We start with linear patterns. Linear patterns are for grade 10, 11, and 12. You should be familiar with linear patterns. Of course, we did linear patterns in grade 8 and 9. And that's the formula that we use. All right, let's put that to some application, do a little bit of revision. Question 1 is very straightforward. You're being asked to use the diagram to complete the table, and that's easy. So all you do here is you would count the number of matchsticks. So let's start with pattern 1. We've got 1, 2, 3, 4, 5, 6 matches. So that's 6. For pattern 2, look what happens. You don't need to calculate all the matches again. Just look at the matches that were added. So how many were added? 1, 2, 3, 4. Okay, so 6 plus 4 is 10. And then how many matches were added? Again, 4. So as you can see, each time 4 matches are being added. That's why this is a linear pattern. The first difference is always 4. It's always the same. Okay, so if we go to more questions, let's find the n term, and of course we know the linear pattern equation. Okay, so let's put the numbers in the table into the equation. Of course, A stands for the first term. In this case, A is 6. And the D is for the difference. There's a difference of 4. We add 4 to the next pattern. And of course, if we simplify the equation, 4 times n is 4n minus 4, which of course becomes 4n, and 6 minus 4 is 2. Okay, that would be our n term. Which pattern number is 206 matches? Again, we will use our Tn formula for a linear pattern. From the previous question, we know that that is our linear pattern. Okay, and this time they're asking us which pattern number. So we are looking for Tn this time. Has 206 matches. So which Tn will give us 206? So we could just make our Tn 206. And of course, if we are simplifying this, it will become, okay. All right, so if we divide both sides by 4, 204 divided by 4 will give us 51. Right, so you can see that 204 divided by 4 will give us 51. So that will be the 51st pattern. The 51st pattern will have 206 matches. Okay, that's it for grade 10. The next section, the quadratic pattern, will be for grade 11 and 12. Okay, and of course this is the formula we use for a quadratic pattern. And let's get into it. All right, let's start by working out the difference first. Okay, the first difference, of course, these are the terms. It's term 1, given terms, term 2, term 3, and so forth. Okay, we've put them again here. So to work out the common difference, you subtract term 2 minus term 1 will give you that difference, right? 4 minus 1 is 3, and you do the same thing. 11 minus 4 gives you 7, 22 minus 11 gives you 11, 37 minus 22 gives you 15. Alright, so that is your first difference. This is how we work out our first difference. And of course, the second difference, you would work it out the same way. So you would say 7 minus 3 gives you 4, 11 minus 7 gives you 4, 15 minus 11 gives you 4. So we can see how this works. And of course, the second difference is the same. The second difference is 4. All right, this is why this is a quadratic pattern, because for a quadratic pattern, the second difference is always going to be the same. We said for a linear pattern, the first difference will be the same. But for a quadratic pattern, the second difference is the same. Okay, moving on. Find the next two terms, and that should be easy. All right, so 15 plus 4 will give us 19, and 37 plus 19, let's check that. 37 plus 19 will give you 56. Okay, remember when you're going forward, you're adding, so 37 plus the 19 will give us 56. And of course, we are looking for two terms. This is term 6. We are also looking for term 7. So let's add 4 again. 19 plus 4 is 23. 56 plus 23 will give us 79. So our next two terms will be 56 and 79. All right, let's move on. Okay, now we get to the interesting part, and for grade 12s and grade 11, this is always in your exam, so you need to understand this. And of course, you can do this in two ways. I prefer to use the T0 formula. Okay, so let me show you how to do that. But of course, if your teacher hasn't taught you the T0 formula, don't use it. Okay, so how does the T0 formula look? Okay, of course, this is our equation, and we need to find A, and we need to find B, and we need to find C. To find A, you need to take the second difference and equate it to 2A. So to find A, you'll say 2A is equal to the second difference. And of course, in this case, the second difference is 4. So we'll say 2A is equal to 4. All right. So therefore, A will be 2. Okay. All right. And before we find B, we must find C. And what is C? C is T0. This is why we call this the T0 formula, because we must go back to T0. Now, how do you go back to T0? Okay, we start at this point. 3 minus 4 will give us negative 1. Okay? 3 minus 4 gives us negative 1. Okay, just to double check. It's negative 1. Okay? And of course, we want to get back here to T0 because our T0 is equal to C in the formula. So C is actually our T0. So to get back to our T0, then we would then take the 3. All right, so we are here. So we'll take 1 and we subtract the minus 1. Remember, we're going back 1 minus 1. Okay, so this would be 1 minus negative 1. Just going to put that in brackets because it's a negative number. Will give us a T0 of 2. So that means our C is also 2 because our C is equal to T0. And then finally, we work out B. So you start with A and C, and B, you'll work it out at the end. And this is how you work out B. You'll say that A plus B plus C must equal to T1. This is how we are going to work out B. So I repeat, when you are working out the quadratic pattern formula, always start with A and C, and of course you will use A and C to work out B. So the value of A we worked out was 2. B is what we're looking for. C is also 2, and T1 is 1. Okay, so if we solve this, it will be 1 minus 2 minus 2, which is negative 3. Okay, and once we have all three, A, B, and C, then we can write out our quadratic formula, which would be, we know that A is 2, 2n squared. We know that B is negative 3, so it's negative 3n. And we know that C was also 2, so positive 2. And that is our quadratic formula. Okay, I've rewritten the quadratic formula there. So find the 10th term in the sequence. That's easy. All you do is you substitute 10 where there's an n because we are looking for the term. So 10 squared, wherever there's an n, we're just going to substitute 10. Okay, to work that out. Okay, it's 172. Right, that was easy enough. Let's move on to the next question. Is 752 a term in the sequence? Okay, so that's easy. We could just check. Let's equate Tn to 742. We know our formula there on top. So we want to equate the Tn to 742. So let's do that. And of course, we will solve the quadratic equation. And of course, we can use our quadratic formula to solve this, which would be minus b. Okay. All right, and again, the quadratic formula is given to you in the formula sheet, so you don't necessarily have to memorize it. So let's use it here. Okay, we've got negative 3 plus. I'm going to start with plus. All right, negative 3 squared. All right, so first of all, we get an n of 20. Okay, we could check the negative number. It'll probably not be a term, but let's just check it just the same. If we check the negative option, all right, okay, because that's not a whole number, of course, that's not going to be a term in the sequence. A term can only be a whole number. So yes, this is in the sequence and it's the 20th term, right? Because 20 is a whole number. The other option is not a whole number. Therefore, it's not a term in the sequence. Let's move on. All right, okay, this is the end of the video on number patterns. The next part, which is your sequences and series, would be for grade 12s only. All right, so please look out for that video, grade 12s.